Indian classical music is considered so divine and can be traced back all the way to Sama-Veda, one of the 4 Vedas in Hinduism. Even in today's generation, the interest for learning this art form can be seen in young minds. Musicologists and researchers across the world are trying to analyze and generate Indian music, but they find it very difficult, as Indian classical music is not just a bunch of scales or chords. It is much more than that. This is where our project comes into the picture. Bhargava Swara is a Python library that we have built that simplifies the job of a researcher or student who is trying to analyze or synthesize music. Hello, we are Team Shouryaanga Tribe, and this video will walk you through everything that we have done in the last 2 months. Part 1. Research papers. Teaching music to machines is easier said than done. Finding and understanding some quality research papers on this topic was the most important and challenging step for us. We were able to grab a lot of key information from them. Professor Xavier Sarah, Professor Hemanth, Ajay Srinivasamurthy have done some great work on this topic. Part 2. Analysis and synthesis. Indian classical music contains 2 main traditions: Hindustani music and Carnatic music. Every classical song contains a raga, a melodic framework that brings mood to the song. It defines whether a song needs to be happy, sad, energetic, devotional, etc. Thala, which is like a hand-gestured tempo. It is the hand movement of the singer while performing. It represents time, and a thala stopped means the life of a song is stopped. Gamaka and instruments also play a key role in bringing a song to life. Okay. Now we will jump directly to the MVP. We have already built a library on Indian classical music, and you can watch that in PyPI. Please go through the documentation to see what it can do. All the user need to do is to type pip install Bhargava Swara in his terminal, and it will do the rest of the job. For example, if the user need to generate spectrograms, all the user need to do is to import them from the library. But if the user need to perform analysis or synthesis tasks like raga recognition or ornamentation detection, they may need something called a Gemini API key. For this, the user need to have a Google account, and he should get his own private Gemini key from Google iStudio that he can later use in the code. Part 4. Unique selling point. Here comes the obvious question. What's the point of doing all of this? Our solution may not be saving lives or curing diseases, but we genuinely care about our own culture and heritage. Research scholars, students, music enthusiasts, each of them have their own use cases. We are also building a mobile application using Flutter with tools from this library, which can have a huge impact in Indian music community. On 6th of April, we attended a workshop on AI applications for Indian music in IIT Hyderabad, and the speakers were the people who I mentioned previously as the authors of research papers. We have shared our idea there, and the idea of using Gemini APIs to perform these tasks surprised many people. The idea is in the community now.